All right, hello everyone. Today what we're doing is we're just doing a little trig extension. We're trying to get you all ready for the MCAs and ACTs and just a good trig practice from what everyone did last year in geometry. This is day one. We will also have a second day to kind of almost do the opposite of what we're doing here today. Okay, now before we even start any of this, before we get into this triangle business, I need you to go to your calculator and, oh, sorry, that's there from before. And what I need you to go to, I need you to go to mode, and you need to be in degrees. So if everyone looks at your calculator, you're going to have the radian highlighted. We need to be at the degree needs to be highlighted. Okay, so hit enter. And you will know right away if your calculator is not in degree because you're going to not have the same answers as me the entire time. So make sure you are in degree. Now we're going to be using sine and cosine and tangent. So those are the buttons that are all right here. These are the ones that we're going to be using the entire time for our calculator. Now your calculator is going to be doing a lot of the work for you today, which is really, really nice. All right, so let's begin. A lot of this should be a review of what we have done in geometry. All right, so if I say the phrase SOHCAHTOA, that should sound very familiar if you had geometry last year. So the SOA is talking about sine, and you have opposite over hypotenuse. The ka, as some people would say, would be your cosine, which is adjacent over hypotenuse. And then finally your TOA, the tangent, is opposite over adjacent. So these three kind of equations here, these are your most important equations that you're going to be using. Okay. All right, so these three triangles kind of show what we mean. Like, what do we mean by opposite, adjacent, hypotenuse? So if you have a triangle that gives you the opposite and a hypotenuse, again, we're talking about sine. If we are given the hypotenuse adjacent, again, we're talking about cosine. If you are given the opposite and adjacent, we're really talking about tangent. So if they give you a triangle and they're giving you certain sides, you should know right away, based on SOHCAHTOA, what do you need to know, okay? All right, so these next three steps are basically your basic steps that we're going to be doing the entire time. We're going to look at our triangle based on what we are given. Should we use sine, cosine, or tangent? You're going to write the equation, and then we're going to solve the variable. Okay. All right. So a majority of what you're expected to do is going to look like this. We're going to have triangles. We have to look at what they give us and solve it from there. So as we can see here, we have our angle here. And I always like to label everything because it kind of helps you what I need to know. I need everyone to remember your longest side, your diagonal, is always your hypotenuse. Okay. If my angle is here, that means the opposite side is over here. That's my x. And that would mean the side length right next to the angle is always my adjacent. Okay. So I see here that we were given the opposite and the hypotenuse. So because of that, we know we're going to use sine. So we're going to have sine and then 51. The only reason why I'm putting parentheses for this is because your calculator is going to do that. And I like to write it how our calculator is going to do that. All right, so we have for sine, reminder, it's always opposite over hypotenuse. I just always remember hypotenuse is always bottom. Hypotenuse is always bottom. Okay, so we're going to have x over 4. All right, so now we're going to do a little algebra skills. I'm going to take this sine 51 over 1, and now I'm going to cross multiply. I'm taking this 1 times x, and if I have 1 times x, we're just going to have x. And then I'm going to multiply this 4 to the sine 51. So what I really have is 4 times sine 51. And now from here, what's really nice is we're just going to plug this in. I'll plug this first one with you guys, but I think you guys will figure out how to do the rest of these, and I'll let you guys do the calculator work. All right, so we're still here, so I'm just going to exit out of this. So I'm going to hit second, quit. All right, so we're really taking 4 times our sine, and it was 51. Okay. And obviously we're going to round. I'm going to have you guys round that to 3.11. Okay, so I'm going to go back to our notes real quick. And I'm going to make this full screen because I think you guys can do the calculator stuff without me at this point. All right, so when we plug that into our calculator, we ended up finding x equals 3.11. Okay, a quick check, ladies and gentlemen. We know our hypotenuse, our longest side here, should always be the largest. Well, if this is 4 and I have this not hypotenuse side, I know it should be smaller than 4, and it is. So we know we did that part of it correctly. All right, that's the basic how we're going to do all of these. Each one of these kind of has something different, so I'm going to go through these a little bit faster, but I think you guys are going to catch on kind of what's going to happen every single time, and you can start maybe skipping a couple steps because the same pattern is going to happen every single time. All right, so we have this angle here. This, our long side, always our hypotenuse. This time, this side is right next to it, so that would be my adjacent, and this one is the opposite of it. Well, we were given hypotenuse and adjacent, so because of that, we are going to use cosine. So we're going to have cosine of the angle 36, and adjacent is on top, hypotenuse is always on bottom. We're going to solve this in the same way. I'm going to put that 1 underneath, so 1 times y is just y, and then I have 10 times cosine 36. Okay, again, you're just going to grab your calculator. This time, instead of sine, you're going to do cosine. So you're going to do 10 times cosine 36. And when we do that again, we're going to have to round, and I'm going to have y equals 8.09. Again, we were given a hypotenuse of 10, so I know this side should be smaller, and it is, so we did that correctly. All right. So those are, again, kind of our basic ones. So if we've used cosine and sine, I think you guys know this next one's going to be about tangent. So this one is our angle. This is our opposite of our angle. This is always our hypotenuse. And this one is our adjacent. So as I can see here, we were given opposite and adjacent. So that means we're going to use tangent. So our angle is 19. And we're going to have z over 12. And I think you guys are seeing the pattern here. I'm not even going to set up the cross products. I think you've seen what's going to happen. What I'm really going to have here is I'm going to have z equals 12 times tangent angle 19. Okay, so again, grabbing your calculator. This time we're going to use tangent, so we're going to take 12 times tangent and then 19 in the parentheses there. And when we get this one, we're going to have z equals 4.13. All right, so these are all kind of our basic ones. You're going to see a couple of these on your homework today that you'll set those up and solve those. Okay. Our next three, you're going to kind of see a pattern that's going to happen here again. It's going to be a little bit different though, but basically the same concept. I'm going to look at my angle. I'm going to look at what I was given. So I see I have opposite then and hypotenuse. I'm just going to write in adjacent just so we can get in a good habit. And so we were given opposite and hypotenuse, so I know I'm going to have sine. Our angle was 23. Hypotenuse always goes on the bottom, so I'm going to have 7 over a. We're using a, sorry. So already we can kind of see this is different from our last three problems. The last three problems, your variable is on top. This time our variable is on bottom. So our solving is going to be a little bit different. I'll set up this first one and you're going to see like, oh, that's what's going to happen every time. So I'm going to put a 1 under here. I'm going to cross multiply. I'm going to take 1 times 7, which is 7. I'm going to multiply this a to the sine 23. So I'm going to take a times sine 23. Well, if they're timesing and I want to get a on its own, to get rid of the timesing, I would divide. So I'm going to divide by sine 23. So that's kind of the difference here between our first three and these next three. The first three, the a or the z or whatever was on top, so that means you multiply to solve. This one, the a is on bottom, so we're going to divide to solve. So again, you're just going to grab your calculator and you're going to take 7 divided by sine 23. And when we do that, I'm just going to write it up here. I've run out of room, so I'm going to say a equals, And we are going to get 17.92. Now again, think about this. We just found hypotenuse. Hypotenuse should be our longest side. So that's why it kind of makes sense that that side length is so much larger than before. Okay, so that's basically the difference between these different types that we're going to find. You have to figure out when to multiply and when to divide. Okay. All right, so this next one, my angle is up here this time. The side length right next to it is adjacent. This is always my hypotenuse, and I'm just going to write an opposite. And so based off this, I know I should use cosine, so I'm going to say cosine 72. I know my adjacent. I don't know hypotenuse. Again, I see B is on the bottom here, so what I'm really doing again, I'll show everyone just one more time. I'm going to take 1 times 18. We have cosine 72 times B, and to get rid of that, I'm going to divide. Okay, so we're going to divide. So grab your calculator. We're going to take 18 divided by cosine 72. And when we do that, and again, reminder, you're finding hypotenuse, so your answer is going to be a little bit bigger. I'm getting 58.25. I'm going to say this one more time. If none of your answers have been the same as mine, it might be because your calculator is still in radian. So absolutely make sure your calculator is in degree. All right, our last one here. So obviously, if we've used sine and we've used cosine, I think we all know this one's going to be tangent. So I have this angle here. This is my opposite, and this one's my adjacent. I'll just write hypotenuse because I can. And so we know we're going to use tan. So I have the tangent 64. We have opposite over adjacent. I'm actually going to go straight to kind of solving this one. So I know I'm really going to have C equals 14 over tangent 64. Okay, so again, grab your calculator, plug that in. This one is not the hypotenuse, so we don't expect it to be larger. And I'm getting 6.83. All right, so those are just kind of our basic how do you use SOHCAHTOA, when and why you would use each one. All right, so those are kind of our basic, that's how you use them. And now what we're actually going to do, if we look on the next page, we're actually going to apply this to word problems. So this is actually what we're really here for. This is what would actually be on your MCAs and your ACTs, is that they would actually have word problems and they would expect you to apply that, okay? All right, so we see we have this tower here. We see we have an angle of 60 degrees. And our first question is we have this tower, and I'm actually just going to draw this triangle down here again, just so I actually know what I'm doing. And we have that angle of 60 degrees. And it says we are standing 10 feet away from the triangle. So if we are here and the tower is this thing here, how far away? So we are 10 feet away from that tower. And we want to know how tall that tower is. So we don't know this over here. Well, right now it appears based on all of our side lengths, it looks like we have adjacent and opposite. So that means we're going to use our tangent. So we're given 60 degrees. We don't know the opposite, but we do know our adjacent is 10. I'm going to jump straight to kind of solving because I'm hoping we started seeing some patterns. If my variable is on top, that means we're going to multiply. So my answer is going to be x equals 10 times tangent 60. Okay. So we do have a word problem. We should make sure we're labeling it. And we do have a tower, so hopefully we know it's going to be a little bit taller. And I am getting 17.32 feet. Okay. The next one, on the other hand, we have different information. We still have the tower. We are still standing at an angle of 60 degrees. This time, though, we know the tower is 15 feet tall, but we don't know how far away we are standing. Okay. So again, based on what we're given, we're going to use tangent. We still have 60 degrees. This time though, our information is kind of flipped. So what I'm really going to have is I'm going to have 15 over x. Now again, since x is on the bottom, that means we're actually going to divide. So I'm going to say x equals, and we're going to have 15 over tangent 60. Okay. So grab our calculators, divide, and we are going to get 8.66 feet. Okay. So those are just some questions you might see on your MCA's ACTs. Obviously, they look very similar, and that's kind of why we have them, is we want you to see when and why you would use each one. And so obviously just missing one little phrase of like, are you standing next to it or are you finding the height of the tower? You really need to know like what are you actually finding and what are you actually given. All right, our next two are word problems, but you kind of have to kind of read through and see what they're actually asking and see what's going on. All right, so some of you might have seen this. So this is the large glass pyramid at the Louvre in Paris, and it has a square base there. And we're given the angle at the ground, which is at 49.7, and we want to know how high that pyramid is. So if you're looking at your notes or if you're looking at my slide here, we have a little triangle that's inside there. So I'm going to pull that little triangle out to the side here, and we see we're given this. This angle right here is 49.7. We're also given this, and we're really asking for the height, so we're asking for that x there. Now the other piece of information we're given is that this whole side length here is 35. But we're not going to use that because if we look at this triangle here, we see that it's really half the distance of that. So we're really going to take this 35 and we're going to divide it by 2. And when we do that, we're going to get 17.5. So that's actually our side length here. Okay. So again, if we look at what were we actually given, we were given the opposite and adjacent, so I know I'm going to use tangent. Okay. And we have opposite over adjacent. X is on top, so I know I'm going to multiply. And again, we're just going to grab our calculator, put all of that in. Keep in mind we are finding the height of a giant glass pyramid, and also we're in Paris, not here where they measure in not feet. So when we plug this all into our calculator, we are going to get x equals 20.64 meters. All right. So that one just kind of had a twist in there that you just had to take that side length and divide it by 2. So just kind of be aware that on your ACTs and MCAs, really look at what they're giving you and see like, do you have to change one of your side lengths? Do you have to do something to it? All right, here we go. Our last two, and again, these are kind of right out of ACT and MCA prep. All right, so we have an airplane. And its angle of descent, so descent means it's going down. So it's going down into the airport is 3 degrees. Okay, so as like we wouldn't want an airplane to be going down really fast, so it's going down at a slow degree of 3 degrees. If the airplane's descent is at an altitude of 5,000 feet, so altitude means how high that plane is, we want to know what the straight line distance to the airport. All right, so we have an airplane. I know you're thinking, Bayles, you're such a good drawer. All right, so it's descending, so it's going down. Okay, already this looks fantastic. All right, and we have the ground here, okay, and we know that it is going down at 3 degrees. Okay, we also know that plane has an altitude, so a height of 5,000 feet. All right, we want to know the straight line distance. So really we want to know is if the plane is here, how far does it take to get to here? So what we're really finding is our hypotenuse. So right now, based on what we were given, we are given our opposite and our hypotenuse. So because of that, we're going to use sine. So our degree is 3. Our opposite goes on top. Hypotenuse always goes on bottom. So right now, since my variable is on bottom, I know I have to divide. So I'm going to say x equals. I'm going to take 5,000 divided by sine 3. So right now, we should keep in mind we're finding a plane that's descending. We're also finding our hypotenuse, so we know we're going to get kind of a large number. And also, we should label this with feet. Okay, so I'm going to say x equals, and yeah, this number is humongous. But we're going to have 95,536.61 feet. Okay. So again, keep in mind these are going to be problems that you have to kind of actually read and see what are they actually asking us. Okay. All right, our last one, and terrible news, it is bringing back something else from geometry from last year. Luckily, it's something that's not too crazy. All right, so you are given a trig ratio. You can find others by drawing a triangle and using the information you were given. All right, so right now we know sine, and I want to know what cosine and tangent are. Okay, so I'm going to draw what they have given me. So I'm going to have a triangle, and I know they gave me angle A. Now reminder, when we find sine, sine is really opposite over hypotenuse. So if this is my angle here, my opposite would be over here, so I'd put a 3 there, and my hypotenuse is always that diagonal line. Now to find cosine and tangent, reminder cosine and tangent, cosine is adjacent over hypotenuse, and tangent is always opposite over adjacent. So right now for both of these, we need to know adjacent, and that's not something we're given. But if we remember, also back to geometry, we have an equation that helps us find when we don't know a side length, and that is going to be the Pythagorean theorem. So reminder, that's a squared plus b squared equals c squared. So let's plug in what we know. I'm going to put that a is equal to this 3, so I'm going to say 3 squared. We don't know this side length, so I'm just going to keep it as a b. We don't know it. And reminder, your c is always your hypotenuse. All right, so now we're going to do a little algebra to help us out here. I'm going to say 3 squared, which is 9. We don't know b. And I have 5 squared, which is 25. We got to solve for b squared, so I'm going to subtract that 9 from both sides. So now I have b squared equals 16. And to get rid of the square, we're going to square root. Now, right now for this problem, we're getting a really nice answer. We're going to get b equals 4. Okay. On your homework, or if ever you don't get a nice answer, you could certainly leave it as the square root of whatever number you're in. Unless they ask you to round to the nearest hundredth or something, obviously then you would plug it in. But let's say if you had like the square root of 15. The square root of 15 is a really gross number. I wouldn't want you to write that, so I would just have you keep it as a square root of 15, unless on the MCAs or ACTs you're told to do the opposite. Okay? All right, so now let's put this all together. We have our triangle, we have angle A, we were told this side length is 5, this one is 3, and we just found out this new one is 4. Okay, so now we're going to find cosine and we're going to find tangent. So cosine, reminder, is adjacent over hypotenuse. Well, we know now it's going to be 4 over 5. So that's our first answer. Tangent, they told us it is opposite over adjacent. Well, now we just found that, so it's going to be 3/4. All right, so this problem is basically taking a combination of everything we know. All right, we will see you next time for triangles day 2. All right, thank you.